Hello everyone and welcome back to another video, and today we will be working the January 2022 paper 2 question 9. So let's go. So this is under the section of geometry and trigonometry. The question 9.8 says the diagram below shows a circle with the points P, Q, R and S lying on its circumference and its center, which is marked by O, and it says RP is a diameter of the circle and AB, so this is AB, is a tangent to the circle at P. So this is the point at P where the tangent meets the circle, and it says angle APQ is equal to 3x degrees, angle QPR is equal to 2x degrees, and angle RPS is equal to x degrees, and angle QSP is equal to 54 degrees. Part 1 says, determine the value of each of the following angles, show detailed working where possible, and give a reason for your answer. And the first one they want us to find is x. Now the thing is, even though they want us to find x, we're not going to look at our diagram and say, oh, we're just going to use from this single x right here, because in this case it won't necessarily be possible. So what we're going to start with is, what we know is that this tangent, when the tangent meets a circle at the point where it meets and is being intersected by some lines kind of perpendicular, in this case this is the diameter, two right angles are formed. So a right angle is formed here. So let's draw that and show you. So actually a right angle is formed here, and a right angle is formed here. So this is 290 degrees. So what we know is that from this area then where 90 degrees is formed, this 2x degrees plus 3x degrees would be equal to 90 degrees, and that is the information that we'll be using to form and find x degrees. So what we know is that 2x degrees plus 3x would be equal to 90 degrees. So 2x plus 3x, that will give us 5x is equal to 90 degrees, and now we can go ahead and solve for x. Therefore x is equal to 90 divided by 5, and therefore x is equal to 18 degrees. So this 90 degrees, we couldn't use this side because we don't know what the angle here would be. So therefore this x is equal to 18 degrees. And the reason that we're going to use is that angle formed by a tangent, which the tangent is AB, resulted in 290 degrees. When intersected by the diameter PR. So basically what we're saying, so from PA, which is where the tangent meets the circle, so from PA being intersected with the radius OP, or the diameter RP, it forms a 90 degree angle. And that is our answer for part 1. In part 2, now they want us to find y degrees. So we know that x is equal to 18 degrees, which we just found. So therefore, this right here is 18 degrees. If we wanted to know 2x, we'd multiply x by, which is 18 by 2. If you wanted to find out what right here is where the 3x, you'd multiply 18 by 3. But now they want us to find y degrees. Now we are treating this as a triangle by itself within the circle. So this that I'm outlining. So this is a triangle by itself. So the reason that we're using here is that the sum of the interior angle of a triangle is equal to 180 degrees, which is what we know. But first, we have a missing angle here, and this is a triangle in a semicircle. So what we can say is that angle RSP is equal to 90 degrees. And this is angle in a semicircle. So angle in a semicircle is equal to 90 degrees. So that's the first thing we have to identify, because there was a missing piece of the angle right here. So what we can say is that angle RSP is equal to 90 degrees. And the reason for that is angle in a semicircle So angle in a semicircle is 90 degrees. So that's the first thing that we had to identify. Now we can go ahead and solve for the angle y. So what we can say is that y degrees plus 90 degrees, which is the 90 degrees here, plus 18 degrees, which is the 18 degrees which we found here, is equal to 180. And now we can say, therefore, y plus 90 plus 18 would give us 108 is equal to 180 degrees. So therefore, y is equal to 180 minus 108. So the 108 was adding here, so when it comes across, it is subtracting. And therefore, y is equal to 72 degrees. And as we said, the reason that we're using is that sum of interior angles in a triangle is equal to 180 degrees. So these are the two reasons that we use and the two workings. Part 3 now, they want us to find z. So this z right here. So what I'm going to put in, we just found what y is, which is 72 degrees. So what we're looking at is this right here and this right here. So what we know is that both these triangles lie on the same chord, which is this chord SP. And that is the reason that we'll be using to say that angle Z is equal to 72 degrees. So we're saying that Z is equal to 72 degrees. And the reasoning that we're using is that angles on the same chord are angles in the same segment. So we can use it by a segment, because remember, this is a segment and this here is a segment. So a segment is being separated by a chord. So a smaller segment here, but both are in the larger segment. So we can use two reasons, which I'm going to list two. So angles in the same segment are equal, or you could have used angles subtended by the same chord, which the chord is SP, are equal in sides. So any one of these reasons and you would be good. So angle Z is equal to 72 degrees, which is the same as what Y degrees was. We're now on to part B, and it says the diagram below shows straight roads connecting the towns L, M, N, and R. And it says LR is equal to 18 kilometers, LN is equal to 12, and MN is equal to 10 kilometers. And angle RLN is equal to 25 degrees, and angle LMN is equal to 88 degrees. And it says calculate angle MLN. So what we're going to do, basically, as we all make mistakes. So calculate angle MLN. So from looking at this, so we're highlighting this, so we're using this triangle. So let me highlight it. So we're highlighting this triangle here. So along this line, which means that I'm using these data, so the 88 degrees, 10 kilometers, and 12 kilometers. From looking at it, what I know that we can use is our sine rule. Because remember, with sine rule, if you're looking for the angle and you have two known sides, then you can go ahead and find. So sine rule, it states that basically sine A being divided by the length you can use as A is equal to sine B being divided by B. So A and B are the two lengths basically. So therefore, what we're going to use is sine A. So we can say we're finding sine A. So we're using here sine A with A being 10 kilometers, and then using this as sine B, 88 degrees, and B being 12 kilometers. So therefore, what we'll have is sine A being divided by A, which is 12 kilometers, is equal to sine B, which is as 88 degrees, being divided by B, which is so this is actually the 10 kilometers. So if here sine 8 is the length that is opposite it, so this is 10, and now for the 88, the length opposite it would be 12 kilometers. And now we can go ahead and solve. So now what we're saying is that sine A is equal to, we're carrying over the 10, so it's dividing here, so when it comes across, it will be multiplying. So what we'll have is sine 88 being multiplied by 10, and that is divided by 12. So therefore, sine A is equal to, so when we do sine 88 times 10, sine 88 times 10, we'll get 9.99 being divided by 12, and we get 0.8328. Now we can solve for A, so therefore A, which is the angle that we're now trying to find, it would be equal to sine inverse of the 0.8328. And when you do that, what you'll get is 56, or rather A, which is the angle, is equal to 56.4 degrees. And that would be our answer. So as I said, this sine A, so each length is opposite to the angle. So 88 is corresponding to the 12 kilometers. And this side that we're looking at, angle MLN, is opposite to 10 kilometers. So that's why we have sine A over 10 and sine 88 over 12 degrees. Our angle is 56.4 degrees. Now part 2 wants us to calculate the distance NR. So now this is a triangle that we'll be using to calculate NR. So we're using this side. So if you're realizing that these are actually two triangles that were joined. So that is it. So now we have two sides and a length. So what we can use here is our cosine rule. So we're going to use our cosine rule here. And what we know from our cosine rule is that c squared or let's say c is equal to the square root of everything, because we're taking the square from the c already. So it will be a square plus b square minus 2ab, and a and b, guys, are the known sides, which in this case would have been the 12 kilometers, the 18 kilometers. C is our unknown side, or C is a side that is opposite to the angle which is given in your triangle. So these are our known sides, and C is the side that is always opposite to the angle which is given. So 2AB being multiplied by cos theta, or cos the angle. Let's see if we find that sign. Cos theta. So it's a square root of all of that. So therefore, C is equal to, now writing this out. So A, we're using A, let's say 12 kilometers. So that is 12 square plus B, which is 18 kilometers. So 18 square minus 2 being multiplied by 12 being multiplied by 18 being multiplied by cos theta, which we're using as 25 degrees. So C is equal to, so the square root of 18 square plus 12 square, when you put that in your calculator, that will give us 468 minus 2 times 12 times 18 times cos 25. That will give us 391.52. Now we can do a subtraction. So therefore, C is equal to the square root of 468 minus 391.52. That will give us 76.48. And when you do the square root of that, C therefore is equal to 8.75, or units is kilometers. So C, the length or the distance of NR. So therefore, NR is equal to 8.75 kilometers. So that would be our answer for the distance NR. So we use our cosine rule. The question before, we use our sine rule because we had two angles and was looking for an unknown side. Part 3 now wants us to determine the bearing of tone R from L. Tone R from L. So basically we're just adding the degrees that moves from tone from right here to here. We know the missing angle here because we calculated it to be 56.4. So remember when we're looking at the sine rule, yes, in part 1 of the question here. So this 56.4 is this angle here that we calculated, which is angle MLN. So this is 56.4. So now what we're looking at is tone R from L would therefore be all of this, and that would be the bearing. So all we're doing is adding the total degrees here. So therefore tone R from L is equal to 50 degrees plus 56.4 degrees plus 25 degrees. When you put that in your calculator, so 50 plus 56.4, that is 106.4 plus 25, and that will give us 131.4 degrees, and that is the bearing of tone R from L, 131.4 degrees. So thank you for joining us. Thank you for joining us. Continue to like, comment, share, subscribe. If you have any questions, please feel free to email us or send us a message on Instagram, any platform that you choose, and we'll be sure to get back to you, any platform that you choose. So we'll see you in another video.